Hi everyone, my name's Matt, also known as UKAstroNut. In this video I'm going to start doing a sort of journal club. So a journal club is when some people get together and they read a paper or a letter that's been sent into a scientific journal, and then they discuss the paper and they read through it together and they try to work out what it means and what's important in it and try and understand it. I'm going to try and do that today. So hopefully you can watch this video, you can kind of understand the paper that I'm going to go through, and then you can go off and read it yourself if you want, and you can learn a bit more. If not, you can just enjoy this video. Hopefully you do anyway. So the original paper was by someone called Gall, and there was a sort of a follow-up summary letter by a scientist called Gomez. I'll put the papers in the description at the bottom of the video. And the paper and the letter are describing the formation of dust. So what is dust? Well, if you haven't heard of dust before, it's sort of a collection of particles that are throughout the universe. And they're composed of things like silicon, carbon, and particles like this, and they form these sort of larger structures. Now, when I say large, I don't mean physically this size, but if you have very tiny atoms, they form slightly larger, but these are still very, very, very small particles. Now, dust is really important for several reasons. It's thought that the hydrogen that forms stars initially sort of forms and bonds together on these dust particles, and this is how they form originally. So dust is kind of a progenitor, something that's needed to be able to form stars in the first place. It also, these dust particles, we think, start combining together and get bigger and bigger and bigger, and this is how these sort of very small particles, sort of rock kind of sizes, get together, and then these then form things like the planets and the moons and things like this. So dust basically forms stars, but also we think possibly starts forming planets and moons and things like this. So it really is a key fundamental thing when you're forming everything in the universe. Now, one big question we've had is, how does this dust actually form? We're not really sure the process of what forms it. We think there are two possible ways. We think one, that in very old stars, as these stars get very old, in sort of the outer atmospheres, the sort of edges of these stars, that these dust particles can actually form here. And we also think that when a star explodes, when it dies, it forms something called a supernova, and it's just a massive explosion as this star explodes. And it releases some sort of shock wave that goes outwards. We think that behind this shock wave, and because through the supernova, the dust forms in here as well. We think these are probably the two main mechanisms of dust formation, but there's been a lot of controversy and a lot of questions and things. And this paper and the letter that follow try and discuss whether this is, whether we've seen the observations of dust forming from supernova. So the paper tries to look for dust in a recent supernova called 2010 JL. Now, what they did was they tried to look at the light that comes from this supernova. Now, if dust is present in this supernova, the light will look different compared to if it wasn't. So if you have dust, if you know what the infrared is, if you ever see the police cameras where they show they have a camera where they look at criminals on the run or something like this, and you can see what their heat is like. So you don't actually see them, but you see a sort of heat map. So people appear really bright and really red, and then cool things appear really sort of blue and dark. Well, we kind of use the same equipment, but we look at supernova and galaxies and things like this. And dust in this situation, we can create an instrument so that dust looks very, very bright according to one of these cameras that we have. And so we point one of these dust sensitive cameras at the supernova, and if we detect a sort of a bright amount of light coming from it, then we think that there's a lot of dust there. So they pointed their telescope at the supernova, and they found that there was a significant amount of dust there. And the dust was actually around 830 times the mass of the Earth. So however much the Earth weighs, however much mass is in the Earth, imagine 830 times the number of Earths, and I had that much just in dust. I mean, dust is just tiny particles, so you can imagine how much there was. But actually, this isn't a lot. They were actually expecting quite a lot more, which is kind of strange. And so this is this is one point in the paper that's quite strange, and that they were expecting much more dust, but actually didn't see a huge amount. They also found that the dust grains were very large. So I said to you before that dust grains were sort of particles that joined together and they were quite big. But actually, these dust particles they found by looking at the light, they could tell the size of them were much, much bigger than they expected, which was equally very strange because around us in our own galaxy there's dust everywhere, but the dust we see is typically very, very small particles. And so to see these very large particles was quite strange. Now, we've actually seen large particles before, but we assumed that a lot of the particles would be very, very small. That doesn't quite seem to be the case. Now, the thing is, with a supernova, as I have in my lovely diagram here, is you have a supernova at the centre, and you have this black line, solid line around the outside. It's sort of the shock waves. This is the energy as it's blown outwards. Behind it, just behind it, you get all these dust particles forming. Now, the thing is that supernova, we think, can form these dust particles, but we also think that it destroys them, because the amount of energy, the gas and things, hot gas that are coming from this supernova, we think actually going to destroy these dust particles as well, which is always a bit of a mystery, because we thought, well, it was going to form a lot of dust, but then it was equally going to destroy it and make it back into tiny individual particles. But actually find that because these dust particles are so big, that actually the energy to break them down, the supernova, we think, doesn't actually break down these massive particles. Because they're so big and they're so strong, we think that they can sort of withstand the energy and the heat from this supernova, and they're not actually going to be destroyed. Which kind of solves the problem, because we always thought, as I said, that supernovas created dust, but they also destroyed them. But it seems now that whilst they do create them, and we see evidence of this in this supernova, but actually it seems that the dust particles are so big initially that they're not destroyed. And perhaps they're broken down into smaller dust particles, and perhaps that's maybe how we see these small dust particles arise. Anyway, that's just that's the one paper. As I said, it's by Gall, and then a letter afterwards by Gomez, and I'll put the links in the description and you can find them. This is really, really interesting because it's been a bit of a controversial topic for many years as to how dust formed, and we thought that supernovas may destroy the dust, but there's significant evidence here that this has changed our way of thinking about dust formation. Anyway, thank you very much for watching. Keep an eye out. I'll do more of these videos on different papers in a kind of journal club playlist series thing, so hopefully they're interesting anyway. And the letter, at least, and the paper aren't too high level, so they're actually reasonably okay to, if you're not sort of clued up on your dust or your astrophysics, you can try and read them, and hopefully you can try and understand them, and if not, I hope you just enjoyed the video anyway. Thanks for watching, and I'll see you guys soon.